Alright, in this final video we'll talk about part D, and I'm going to scroll up a bit so we can actually have some space to work here. Now in part D we're given that f prime of 5 is equal to 3. And when you see something like that, yes, it's a piece of information. It means that the derivative at x equals 5 is 3, the slope of the tangent line is 3, but it also means that f is increasing at that point. Second, we're told that f prime prime, or the second derivative of x, is less than 0. And f prime prime less than 0 means that f is concave down. So I find it helpful when I'm given information like that to draw a simple picture of what the behavior of the graph looks like at that point. And so roughly it's going to look like that. It's increasing but concave down. And at x equals 5, we know that the slope of the tangent line at x equals 5 is equal to 3. And what we're trying to do here is we want to use the line tangent to the graph of f at x equals 5 to show that f of 7 has to be less than or equal to 4. So we need to construct the equation of the tangent line at x equals 5. So we need a tangent line, and we're told that the derivative at 5 is 3, and we need a point. And going back to our original table, we're told that when x is equal to 5, y is equal to negative 2. So we have a slope and we have a point, and we're just going to calculate the equation of the tangent line. And so we end up with y plus 2 equals 3 times x minus 5, or y is equal to 3x minus 17. Now when x is equal to, we want to show that f of 7 has to be less than or equal to 4. So we're going to plug in x equals 7 into this, and we end up with y equals 21 minus 17, which is 4. So we want to show that on the actual curve, the value of the function must be less than 4. And the way we do that is by stating that when a curve is concave down, a tangent line will always over-approximate. And so f of 7 has to be less than or equal to 4. So the blue point over on the right has to be less than or equal to 4. And so that does the first part of this. Second of all, we want to use the secant line for the graph of f on 5 to 8 to show that f of 7 has to be greater than or equal to 4/3. So we're given originally that at x equals 8, the value of the function is 3, and we want to use the slope of the secant line through those 2 points to show that, rather, not just the slope of the secant line, we want to use the line that passes through 5, negative 2, and 8, 3 to show that the approximate value using that line has to lie below the actual curve. So we calculate the slope of that secant line to be 3 minus negative 2 over 8 minus 5, or 5/3. And again, we can use the point 5, negative 2. You could have used 8, 3 as well. We end up with y plus 2 is equal to 5/3 x minus 5. And so that's going to be y equals 5/3 x minus 31/3. Plugging in x equals 7. So when we plug in y equals x equals 7, we end up with y has to be equal to 4/3 there. So we want to show that f of 7 has to be greater than or equal to 4/3. And we use a similar kind of reasoning. If tangent lines over-approximate when f of x is concave down, secant lines will always under-approximate. And so f of 7 has to be greater than or equal to 4/3. And that's how we work through that logic there. Okay, that's it for this particular problem.